Okay students, in this video, as I already promised you, in this one I will tell you how to calculate the net gravitational force on B and also be able to tell that what is the angle of that net force with x-axis. So I need you to calculate this net force not only in magnitude but with direction also. So my question is, calculate the angle made by net force on 2m mass, or should I say B particle, with x-axis. So to solve this question, I have already solved the first part of the question in the previous video. We have calculated that F1, the force on particle of mass 2m due to particle of mass m. F1 is 2gm square by L square, and we have written it as 2f. Also, we have calculated the force of mass 3m, F2 as 6gm square by L square, and we have written it as 6f. So what I'm trying to teach you is writing force F1 vector in unit vector form. Not just as magnitude, but in unit vector form. So if this is a vector, F vector, and its magnitude is F1, and it makes an angle theta with an axis, then I can write it as F1 cos theta and F1 sin theta. Now F1 cos theta is along x-axis, so I will write it as F1 cos theta. Instead of theta, I am putting 60 degree because this was an equilateral triangle. So F1 cos 60 I cap plus F1 sin theta, F1 sin 60 j cap, because this is along y direction. So here we have written a force in its unit vector form. The second force F2 is only along x-axis. So we need not to take its components. F2 is only along x-axis. So I will write F2 as F2 I cap. Now the good thing about vector in such unit vector form is you can add them directly. Net force will be F1 vector plus F2 vector, and when you add them, you write them as F1 cos 60 plus F2 I cap. You add the I cap components, and F1 sin 60, because there is nothing here in j cap, there is 0. So F1 sin 60 j cap. Now this is the net force. When I put the value of F1 as 2f and F2 as 6f, after the calculation, basic calculation, cos 60 I am putting it as half, sin 60 I am putting it as root 3 by 2. So after basic calculations, I get net force as 7f I cap plus root 3f j cap. Now this is the net force in its vector form. Got it? So once we have the net force in its vector form, let me draw the net force for you. This is where it will go. It has an x component of 7f and a y component of f root 3 or root 3f. So the direction of net force with x-axis, the angle theta, we can calculate tan theta as perpendicular upon base. The perpendicular is root 3f and the base is 7f. Hence we get tan theta equals to root 3 by 7. That's the way to calculate force as a vector and angle of that force with any of the axes. I hope you get it. It's a very easy way to calculate force vectors. In the next video, however, I will tell you how to calculate net force in case of more than 3 masses. We will take 4 or even 5 masses and then try to calculate net force on each particle.